So this is creating adaptable layouts. And first I'm going to give a brief intro about myself, just so you have some idea of where I'm coming from and the kind of software that I work on. My name is Titus. I live here in Denver, Colorado. I like hiking. That's a photo taken just outside of Sand Dunes National Park. If you have any questions about where to go around here, just hit me up anytime during the conference. And then I'm on Twitter and most other social media things at Titus, and my website is titus.io. And then I work for a company called Mercury, based out of Nashville, Tennessee, and we work with mostly medium-sized to large companies. These are some of our clients, current and former. So that's kind of where I'm coming from. We work on fairly large projects. And today, this is kind of what we're going to talk about, which is all the screen sizes we have to support. And obviously it's a little difficult to see there, so let's break it down a little bit more so we're a little clear about what we're looking at. So these are all the screen sizes from smallest iPhone to largest iPad. And obviously these are not to scale, so don't get confused. I just kind of eyeballed it, just don't use it as reference, but it gets the picture across. These are just the normal physical screen sizes, and then soon we'll probably have something right about here. We don't know what the actual developer screen size will be. The frame that our app is filling, it could be 5.8 inches, it may be 5.5, but either way, it's not unlikely that we won't end up with another screen size to support. And of course, it's not just physical screen sizes. We have to deal with rotation, landscape on the iPhone Plus, landscape and portrait on all the iPads, and of course in iOS 10 we have to support multitasking. So quickly now we're getting up to I think it's about 27 different screen sizes that we need to support, and of course with multitasking it's live when you can slide the multitasking window around, so you need to be able to adjust your layouts on the fly. So it kind of seems like we're just getting to this point where we keep going up and up, and it's getting more and more precarious. And if you still use frame calculation or do all this stuff yourself or break things up into multiple storyboards, you're ending up with permutations that are just not really feasible. So today we're going to look at a few things, starting with the basics about specifically UI TraitCollection, which is an API that's helpful for just kind of segregating these things into buckets. And then also some of the other tools that Apple gives us to adapt our layouts according to screen size. And then we're going to look at view controller containment more specifically, and how we would use view controller containment to isolate a couple pieces of content and then change our layout based on screen size. And then we'll look at adaptive presentations. These would be custom animations, presentation controllers, things like that, where we'd be swapping out the animation and transitions we're using based on the screen size that we're presented on. And then last, we'll take a look at accessibility, which is a big thing that Apple's pushing now. I'm sure most of you have probably seen a lot of the videos that they made, but most of the talks at WWDC, especially around layout-related things, were really hammering dynamic type and trying to get that implemented in every app. So we'll take a look at how to do that. And if we have a little bit of time, I have a couple extra things at the end that we can go through. So first off, what tools do we receive from Apple to handle all these screen sizes? Well, obviously we get auto layout, and hopefully most people are using auto layout. I don't know too many people who are still calculating everything manually. Auto layout's a great foundation for building all this stuff on top of. It gets complicated and has a steep learning curve, but it's the kind of thing that makes this stuff a whole lot easier. And then most recently we had stack views, which is just sort of an abstraction on top of auto layout. It makes doing this stuff a little easier, not having to add 30 constraints every time you want to stack views up. And then we have storyboards. I'm a big fan of Interface Builder and storyboards, and it's worked reasonably well for me on pretty big projects. Obviously there are problems with diffing, and I think there's a talk later today about doing layout code and auto layout stuff in code. So how do we design our layouts and implement the kind of things that designers would hand us? Well, it really breaks into two different categories. So if you have size classes, it's really more of a coarse-grained control over your layouts. So, we used to have pixel-perfect layouts that designers would hand us, and that's kind of going by the wayside. If you went to the typography talk yesterday, there's kind of a good overview of the history of iOS, and I think it's sort of a good point that when iOS 7 came along, we ditched this sort of skeuomorphic UI. We're moving away from that pixel-perfect design and more into a layout that can flow and has extra space and things like that. And I think this is a very good reason for that, for sort of the user choice of multitasking and font sizes. So size classes give us a way to say, are we on a large enough screen that we're going to have a little bit of extra space, which is basically the regular size class, or are we on a smaller screen like an iPhone and the compact width or height, where we might need to scrunch things down a little bit more, maybe focus on a single item instead of multiple items at a time. And so a little bit about the TraitCollection APIs. So in this code example here, we've got just an initializer of the trait collection, and one of the nice things is that we can just give it an existing trait collection and give it another trait collection with a property, and it will just override the whatever property was in the earlier version. So it sort of gives us an easy way to just say, give me everything that we had before, and add on a different size class that we might want to tweak. And of course, you can make trait collections manually, but it gets a little bit verbose, and you'll lose a lot of the information. So these are some of the properties that TraitCollection has. I didn't go through all of them. There's also display gamut and a few others, but these are sort of the most important most of the time. And so we've got the two size classes, which I'm sure you're all probably familiar with. A display scale, which is the scale multiplier that used to be on UI screen, but you can access it through trait collections. So it'll be 2x, 3x. Force touch capability, which might be something you're interested in if you're going to change your layout. If you had a slightly different control for a force touch than you would for non-force touch devices. And then preferred content size, which is newer and is really an accessibility property. So we're going to focus on these three, really. They're really the most useful for most cases. Size classes, obviously, being the main one, and then preferred content size for some of the dynamic type changes. So one of the things you have to understand about trait collections and really any of the UI layer stuff is the life cycle that all of these trait collections are applied when these views are added to the view hierarchy onto the window. So if you're doing work in view did load, or you're reloading cells that are no longer on the screen, those trait collections are not valid, or they won't have trait collections at all. And so when it gets added to the screen, it'll receive its trait collections, and then when it rotates, those trait collections will change. So on the left there, we went from the compact width iPhone to the compact height iPhone, and then iPad doesn't change because it's always regular in this case. So looking at some of the ways we can use that, we can use the size classes to our advantage in laying out multiple pieces of content. The obvious example of doing view controller containment is split view controller, which has been around for a while. And it really just shows a main and detail view controller, and it's just two pieces of content on screen simultaneously. On the iPhone version, it's one at a time, main, and then you tap and it pushes on the detail. So this is a good example of how we can show in a larger screen size, we can show more content side by side with our other content, and meanwhile on iPhone, we can show just a single piece of content and then use the normal navigation. So a similar example to this is the Maps application, which you've all probably used. And it has slightly different layouts depending on what size class you're in. So when you're on the compact width, it uses the search and results section is just a little tiny bar at the bottom that you can swipe up and down. And then when you look at a regular width size class, it moves over to the left since there's enough room to display both the map and your full or most of the results set. And of course, it's the same on iPad. And so it's pretty easy to do this with container views and view controller containment. So we're going to take a look at doing something like that and how you set it up in Interface Builder. Also, we're going to take a quick look at overriding trait collections, which can be useful if you start getting into some of these custom layouts where you might want to override the default trait collection. So in this case, on the iPhone side, it's already compact width. But if you look at the iPad size, it really hasn't changed its width from iPhone. So it really is a compact width container. So we can override the existing trait collection. Otherwise, it would just get a regular with size class, and we can tell it, no, you're actually going to be smaller, and then adjust accordingly. So let's take a look at that. So I have a little application. Get to it. Oh, sorry. So I have an application here. If I can get the mouse over. So it's just a super simple grid of pictures, and you tap on one and it opens, and then there's a button that drills into a mapped view. And that mapped view just has nothing on it right now. So we're going to change that and move this over. So it's really pretty standard. It's just, I already set up this container view because I didn't want to reset up the segues and waste time here. So it just has a container view, and then it links over to this other view controller. And so what we're going to do is just add a container view here to the bottom. And this is going to be that little piece that on iPhone is just stuck to the bottom. We've already got a table view controller down here that's going to act as a similar thing to the search results, and we'll embed that in the container view. And then this is where size classes come into play. So if you go in here to the bottom left, you can just open this up, and normally you just cycle through these devices to change the displayed size, the simulated size on the canvas. But you can also vary by trait. So we can take this and say, okay, we're going to set these constraints up only for this width size class, and so now we get all of the compact width, regular height, which is most of the multitasking side panels, the iPhone, and the smaller iPhone landscape views. So we're already varying, and we can just add our constraints over here. And so these, if you've ever set the constraints up manually, this is just like installing, changing the size classes from the pane over here. So we'll just set up several bounding constraints, then a height constraint, and it'll lock to the bottom there. And then we'll finish with that. That's our iPhone view. And then if you switch back over to iPad, you'll notice that it's no longer satisfied because we don't have any constraints on it anymore. Check over here. You'll see these are all grayed out. They aren't installed. And we could tie that left constraint and add it on both, but it's easy enough to just add a new constraint. Let's go ahead and just move this up here so it's pretty close to where we want it. That's good enough. Okay. So we'll just lock that similarly at 20. We'll put a 20 from the top. And that's all. We're going to give it a height. Let's make it 300. Keep whatever width is there. Which should peg us to the top left. So it's fairly self-evident now at this point that we can just swap between these down here, and you'll see what it's going to do already. But let's just run it. I did, in this version of the code, I removed the map view controller. It seems like map view controller, at least in this simulator, blocks the main thread while it's loading. So it kind of screws up all these animations. So pretend there's a map back there, and it's just, goes to either side. Fairly simple, easy stuff. So the other thing that we can do with this, as I mentioned before, is we can override the trait collection so that it knows that it's no longer in that full width of the iPad. And of course we could figure out what the width is, but that defeats the purpose of the auto layout stuff. So what we can do, we have a container view controller here, and there's a couple ways to do this. You can implement override trait collection for child view controller, and then you can check, for the view controller, I'm checking the class in this case, although you could check to an outlet or something like that. And the alternative is you can actually, I think there's a method on view controller where you can add these. But either way, this works pretty well. And so we're just taking the existing trait collection and overriding the compact size class. And what we're going to do, just as a simple demo, since this is kind of getting chopped off a little bit, which is really just a cell height issue, but we're going to move over here. We're going to hide this label when it's in the compact size. Now this is a new feature in Xcode 9, and it is backwards compatible, so you should be able to use it on iOS 10, iOS 9, where you can actually change this hidden property on views. So you could have different views that are set up for different size classes without having to deal with code. So in this, did that take? Oh, sorry, I need to check. So now it's grayed out, which is Interface Builder's version of showing us that it's hidden. And if we run this now, we should see that the label is hidden. So there, it's gone now. So it's that's a convoluted example of what we can end up doing. Obviously, you can use this to completely change the layout of these cells. If we had a lot more content than we wanted to show on iPad, we could do that fairly easily. Okay, so just to review that really quickly, we're just varying by trait size classes and trait collections. In Interface Builder, you just push that button. It shows you all of the applicable device sizes. And then we also looked at overriding trait collections so that we can tell it that it's no longer a full size on that device, and then we're actually scrunching it down into a smaller size. So the other thing I want to take a look at is presentation controllers and how we would adjust animations based on that. And the example I was kind of going for here is the iOS 11 App Store. And I don't know if, depending on whether you've used it or not, basically you tap on an item, certain items in the collection view, and then they zoom up and show additional details. And it has a little blur effect in the background. So I'm not going to get into too much about presentation controllers. They get fairly complicated, but presentation controllers are sort of broken up into two pieces. There's the presentation controller piece, which handles view hierarchy and some of the background views that are animating, and then animation controller, which handles actually taking the frame of the presenting view, which view you're coming from, which view you're going to, and then allowing you to animate those. And there are a couple ways we could do this. We could return a different presentation controller depending on the trait collection, the size class, things like that. Or we could change the adaptive presentation style if we wanted to use a default one that's built into iOS. So let's look at what we've got here. So we've got our presentation controller and animator set up over here. And they're pretty simple. The animator just sort of scales the view up with a little spring. It actually pulls the view out of the collection view cell and then adds it to the view controller that it's presenting onto, which is a little bit weird, but it kind of achieves a similar effect to what is in the App Store. So if you notice, we basically just have a frame that's set to a constant width. So how would we change this to work in all size classes? So you may have noticed that when I use this on a compact width device, it does not fit. So there's a couple ways to do this. One way, as I mentioned before, is to just override adaptive presentation style. And if we were using a standard built-in presentation style, we could just return full screen or whatever, but we already have this animator set up and we're always using that. One option here is that we can make that like an over full screen size, and then we can change our frame accordingly, depending on the presentation style that we just overrode. And that works fine. It'll just set it, the container view bounds is basically kind of what you make of it, but by default it's just the whole view. So it'll just max out at that view level, and it works fine in rotation more or less. So the alternative is to break this up a little bit more. Instead of having to mix a lot of our frame code in here, we can we can actually just set the end frame to a frame that the presentation controller provides, and that's just another method, kind of like the adaptive presentation style. We can just override it and return whatever frame that we want, and that's really probably a better method of doing this. So instead, right here, we basically sort of just have again, the same hard-coded thing. So we would just check the horizontal size class. If it's compact, we are going to use the full bounds so that we're maxing out at the screen size. And then if we're not, we're going to use this width that is really too big for any compact views. And that basically works the same way. Take a look at that real quick. So it's pretty easy to adjust your presentation controllers if you're using them already, and just you can use completely different presentation controllers. You can use the existing ones you already have and tweak a couple of values like the frame that you're animating between, and it's a really good way to provide a different experience that only could work on a regular size device. So on the iPad we have that extra padding. We can fill it with a blur that makes the spatial awareness of where we're coming from a little more obvious. And on the iPhone we can just take up the whole screen where we really don't have that luxury. So just to review really quickly again, there's sort of two methods for doing this: the adaptive presentation style, which would be a little more useful if we were using a built-in full screen style or something that Apple provides, but since we're using our own animator here, we can also just check it, as you see there in the bottom, to see that it's a certain presentation style and adjust accordingly. Or we can use the frame that presentation controller provides and use that on our animator. So I want to talk about accessibility as well. And TraitCollection provides this preferred content size category property. And in addition to that, in iOS 11 is accessibility category, which is really just a helper for determining whether it's going from the normal accessibility, dynamic type sizes, to just checking that button, which gets you the much larger sizes, which are really intended for low vision users. And that's usually the case you're looking out for, because that's the case where you go from a mostly normal size font to an enormous font that breaks most layouts. So that's an easy way to check really quickly. And so here's some examples of using that. You just check the TraitCollection's preferred content size category, check if it's an accessibility category, or you can just, since these are sorted and they're raw values, you can just check if the preferred content size category is greater than a certain value and just adjust accordingly. The other thing I want to talk about is UI font metrics. And So UI font metrics is new and basically provides a way to scale fonts according to the dynamic type size, custom fonts. So normally it used to be that you'd have to set a system font, but now you can use UI font metrics. And there's several ways to use it. The way Apple usually talks about is something like this, where you initialize a font, give it a size, font metrics with a text style, which is the title, body, heading, all of that stuff. And then you just get a scaled font from that font metrics. One thing to watch out for here, which kind of confused me for a while, is that this size actually has to be the size that you're intending to be sort of the base size of a text style. So this 12, for instance, is not an irregular, like the normal dynamic type size, is not going to be blown up to 20 for a title, for instance. It's 12, and then the scaled font size is sort of the rate at which it changes that initial point size. So if you're like me and you put in 12 and expect it to be 20 or something like that, and spend an hour trying to figure out why it's stuck at 12, it needs to be the original point size that you're going for, and the scaled font is really just sort of a holder for changing that as you change accessibility sizes. So I'm going to show a quick demo of using that. And one of the problems we face a lot is, since we work with bigger brands, we often have to support custom fonts because they have their own version of a font. They want to keep all of their apps branded the same, and that's been tricky to do. It's still a little bit tricky to do because you now have to, if you're using Interface Builder like I try to do, it's not easy to just, use Interface Builder with the text styles. You have to add a bunch of code to use your custom fonts. So I was kind of looking for a way around this. And I've done similar stuff like this before, but font metrics makes this a little bit easier. And as sort of just a demo, we're just going to add an extension on UI label, which is probably not what I would suggest doing, since it will adjust all labels that are produced anywhere while your process is running. So it can happen in mail compose controllers or anything else that are presented. But you can make your own subclass and attach it to that. But for this demo, we're just going to do that. And we're just going to add a UI appearance proxy method that takes a font name and then just constructs a font. And if you haven't used UI appearance, it basically calls these methods anytime this view is created and added on screen. So it will call this anytime a label is created. Then, since we've passed in a name, will basically do the work that we would normally do. And so in this case, we'll take a name, create the font, set to the current, the font size that's already on the label. So if you're using Interface Builder, this will be, what it is set up as the system font size. Then we pull the text style from the UI font descriptor for that font, and that's, the text style like I mentioned earlier. I'm defaulting to body here, although you might just want to not do this at all if it doesn't have a text style. And then you just, this is the same code as before. Just make the font metrics, scale the font, and then set our font up. And this is easy to call from here. Just, UI label appearance, substitute font with name, and then I'm using American typewriter because it's obviously different. So if we run this, all these now are changed to the typewriter font. And if we open the accessibility inspector, so this accessibility inspector is a little bit changed in Xcode 9 as well. It did not used to have dynamic type. It also seems to have, does not really show you which layer is which, so you just kind of have to try it. Probably not that one. It's also sometimes a little bit slow. Well, it's not going to open. Oh, I'm sorry. What we forgot to do. When you set these labels up, by default, it does not automatically adjust these fonts. So we have our label here. We have our text style set. There's this little checkbox. I can't read from here. I forgot what it says, but it's adjusting the font size automatically. And we do need to check this, and I think that basically triggers the scaled font under the scenes to rescale. So should work if I can find my simulator again. Let's reset that. Yeah, so you can kind of see it. I don't know if it's going to change on this one or not. It must be the other one. Yeah, so there it goes. So that's kind of handy. There's a couple ways to do that. It's a fairly easy piece of code to add, and I think it's pretty powerful if we're trying to do custom fonts everywhere. Let's go back here. So a quick little summary of what we've been over. So we went through the basics of trait collections and size classes. We also took a look at size-specific layouts with view controller containment and how we can lay things out and sort of maximize the amount of stuff that we can fit on screen. And we looked at adaptive presentations, how to change our presentation controllers and animation controllers to, have better presentations depending on size class. And then we looked at accessibility, mostly changing the font size, but really you can change any layout depending on the accessibility size. So a couple other things I wanted to go over really quickly. One is with asset catalogs and how Xcode supports size classes and trait collections in asset catalogs. And so in images, you can use, if you see down there at the bottom, there's width class and height class, and so you can set different images depending on those size class variants, and you can also do gamuts and all kinds of other things. And also, I think this is new in Xcode 9, you can add color sets, so you can set up a list of colors that your design team provides in asset catalogs and then reference those in code. And those can also be varied by gamut, and the color space is a little bit easier to see and change here than it normally would be in most of the rest of Interface Builder. So I want to look at one more thing in Xcode, which some people might find useful. If you don't use Interface Builder a lot, or you do a lot of auto layout in code, you might find yourself wanting to, set up your views or controls in playgrounds, and it's fairly simple to do that with, view controller containment, like we looked at before. You can override view controllers, trait collections, and so we can do that in a playground. You see that? So this is our, basic view, and this is actually a little wrapper that Kickstarter open sourced. I think it was on like obc.io or something. And it basically just wraps it up and does the view controller containment and the trait collection override for you. So it makes it really easy to go in here. And this doesn't always autocomplete for me, so well. Let's see. It provides basically a set of devices that you can use. And you can just pass those in to this device parameter. Doesn't always load the first time. There it goes. And now we have, the smaller trait collection. We're not doing anything here, but we could, let's see if this will work. I haven't tried this, but we'll see if we can do this. The other thing you can do is vary appearance traits by a trait collection. So if we want to maybe take this label and do it for UI trait collection, traits, well, let's just do horizontal. Sometimes the autocomplete on these now. So we're going to do compact, I guess. And then we should, well, let's just do background color since that's easy enough. So, let's see if it works. Let's see if the white appearance gets loaded there. It's not reloading. But either way, you get the point. You can do appearance methods by TraitCollection. It may not be loading because it's not early enough. But we can set all this stuff up in a playground and test it over here. So if you had a full control that you had in your main project that you wanted to vary by size class, then you could drop it in the sources directory, just pull it up in here, you just add a view controller, and then this little wrapper, which is fairly simple, you just pass in the view controller you want to take a look at, and then load it in here, and you'll be able to test it as if you were running Xcode normally. Oops. So that's pretty much it. These are some resources that I used when I was researching for some of this. A lot of these newer WWDC talks are pretty helpful with this kind of stuff. It's kind of gotten to the point where this stuff didn't used to be accessible enough and didn't used to be powerful enough for us to be able to build completely adaptable layouts. But now that we have TraitCollection supported in all kinds of things, now that we have custom fonts that can be scaled, it's becoming a little bit more reasonable to do this kind of stuff. So hopefully you found that kind of useful and a few things that you might be able to use in your own projects. So thanks. Any questions? No? Okay, thanks.